So let us begin today's class. This is circular dynamics lecture number 11. And if I go back into the previous class, what we were discussing in the previous class, do you remember? What was the point of discussion in the previous class? What we were discussing in the previous class, let me know. Online students, offline students, what we were discussing in the previous class. No one knows? No one remembers what we were discussing in the previous class? What was the point of discussion in the previous class? What we were discussing in the previous class? No one knows it.
Motion in vertical circle, sir.
What in motion in vertical circle? What we were discussing in motion in vertical circle? If you have to, if you don't remember what we are discussing in the last class, that's a bad sign. Because that means that you have not looked at the notes since last 2 days. And if you have not looked at the notes since last 2 days, well, you will not be able to connect to what we are going to do today. Very shameful that you could not find time to see what we had done in the previous class. Remember, if you come to the class unprepared, not knowing what is going to happen in this class, you will not get anything out of this class. If you think that sitting in the class for an hour is going to get you into a medical college, well, this is the time that you leave this institute and go and find somewhere else, because this is not going to happen. Nowhere in any institute in this universe, anywhere in this universe, can you sit for 1 hour and hope to become a doctor. It cannot happen in India. And try Philippines. You can probably become a doctor by paying a handsome amount of fee without even studying. But in India, if you want to become a doctor and you aspire to get into one of the premier colleges, medical colleges, and you think that sitting in the class for 1 hour is going to get you there, well, you are in the wrong universe. In this universe, it does not happen. So I would request you that this is high time that before you come to the class, the night before, at least go through what we had done in the previous class. Else, this class, the next class becomes irrelevant. It does not matter what we are going to do in this class, because you will not understand a single word of it. Having said that, I'll give you 5 minutes to go through what we had done in the previous class, and then I will ask you questions. So 5 minutes, go back in past and see what we had done in the previous class. I will be back after 5 minutes. 5 minutes to everyone, and then I'll ask you questions. If you don't answer, well, I will know that you know nothing about it. 5 minutes, read what we had done in the previous class. Well, I guess you have gone through. Just to have a recap of what we had done. Okay. So what we were discussing in the previous class, anyone would tell me what we were discussing in the previous class now, since you have gone through that? What we were discussing in the previous class?
Motion on the outer surface of a body, sir.
No, and that is where you are wrong. That we were discussing in the previous
Motion
two.
on the inner surface of body.
Right. We were discussing the motion on the inner surface or motion of a ball or a bob attached to a string. And then we had understood that this type of motion is not confined to a circular path. What do you mean by not confined to a circular path? Anyone tell me? What is the meaning of not confined to circular path? We had discussed this in great detail in the last class. What do you mean by not confined to the circular path? No one knows it? As I said, that is the ill effect of not studying at home, that you don't remember anything. And when you come to the class, everything is fresh. And if everything is fresh in the class, we have lost the battle without even fighting it. Not confined to circular path, what does it mean? It means that it can leave the circular path and it is not firmly attached to the circle. It, if given a chance, it can move out of the circular path. This such type of motion is known as not confined to circular path. And again, this is my last warning to you guys. Since you are now old enough and your 11th standard is about to finish, even now, if you don't wake up, beta, not even God will save you. God will never save you if you don't work hard. But even the hardest of prayers of your parents that spending so much of money bringing you here will not be able to save you, will not be able to get you into any medical college if you don't wake up now. So bacha, please wake up, else it is a lost battle. You don't need to fight it. You don't need to waste your 1 year. Do something else that can bring you more dividends. So not confined to a circular path, it can leave the circular path. And we had seen two types of motion. One is motion on the inner surface of a circular track. One is bob attached to a string. In the motion inside a circular path, normal reaction was giving you the centripetal force. In the motion of a bob attached to a string, tension was giving you the required centripetal force. Do we remember this? Can I have some raised hand that we remember this? Girls, remember? What about boys? Are we sleeping in the class? Or do we remember what we are discussing? Or you were absent in the class, just last one. Boys, do we remember this or not? Okay, good. So tension, again, last warning, beta, please work hard, please steady, please go back and have a look at what we had done in the previous class. Else it becomes impossible to connect to the next class. Then we had seen 4 different points which we were discussing. Point A, the lowest point. Point B, the middle point. Point C, the topmost point. And point D, the left hand side wala middle point. Then we had drawn a diameter BD. Above diameter BD was the upper half of the circular motion. Whether you do it in case A or case B, upper half and lower half. And then we were trying to see how and when and where and under what condition what different things will happen. And we discussed that whatever happens depends on the speed or velocity at the lowest point. Whatever the speed or velocity is there at the lowest point, that determines what type of motion the particle is going to perform. Then we had seen what was the first point. Do we remember? Can anyone read it out from the notes that I'm right there on your screen? Can anyone read out what was the first point and tell me What do you understand by that first point? Tell me. The first point you might have written in the notes if you are making notes. Right now it is on your screen. What was the first point that we discussed? No one can read it out.
If tension or normal becomes zero, the particle leaves the circular path.
If the tension or the normal reaction becomes zero, the particle leaves the circular path. Do we remember this? Yes or no? Okay, that means since it can leave the circular path, therefore the motion is known as, what?
Not confined force.
Not confined to what?
Circular path.
Not confined to circular path. That is absolutely correct. That was point number one. Tension or normal reaction can become zero, and that is how or why it is moving on the circular track. If the tension or normal reaction becomes zero, it can leave the circular path, and therefore the motion is known as not confined to the circular path. We are revising what we are doing in the last class just because we had not studied in the previous class. This is the last time I am doing this, bacha. I hope that you don't repeat this ever again. What is the second point? Tell me. What is the second point? Tell me, and tell me if you understand this, if you remember this. Second point.
Tension or normal can never become zero in the lower half.
In the lower half, that means below the diameter BD, tension or normal reaction can never become zero. So whatever happens in the lower half, unless and until your string breaks, which is not going to happen, or your circular path breaks, the inner path breaks, if that doesn't happen, your normal or tension reaction can never become zero. That means it can never leave the circular path in the lower half. So you can also add this as an inference with an arrow. It can never leave the circular path. It can never leave the circular path in the lower half. It can never leave the circular path in the lower half of the circle. What is point number 3?
It can only become zero in upper half.
Tension or normal reaction can only become zero in the upper half. That means it can only leave the circular path in the upper half of the circle. Upper half means above the line BD. So it can only leave the circular path in the upper half of the circle. I hope we remember this. We are trying to recollect what we were doing. Last time I am doing this. Next time onwards, I am just going to go ahead with the class, bacha. And I'm not going to take the entire previous class in the next class. I'm doing this because I guess you did not find time. I hope this is the last time this happens. Point number 4. What is point number 4?
The lowest point where tension or normal can become zero is B or D.
So, tension or normal reaction cannot become zero in the lower half. It can only become zero in the upper half. The lowest point where it can become zero is the middle point, and the middle points are points B and point D. Points B and D are the lowest point where this tension or your normal reaction can become zero. That was point number 4. We are discussing the various aspects of this motion, and we have tabulated point wise, the important things that you must remember. Any of these points can come in your exam. Please remember them. Very important points. You will not find such elaborate description of this motion anywhere else in any of the books that you have or you have gone across, or any notes that you will ever see in your entire life. Please note them down very carefully and keep them forever. Point number 5. Who is going to read point number 5?
Speed or velocity at lowest point A decides if and where T or N becomes normal.
So basically,
0.
what it wants to say is, that what type of motion this body will have. Body moving on inner part of a circle, or the body attached to a string. The type of motion it will perform, whether T or N becomes 0 or not, whether it will move in the lower half, whether it will go up or not. What is the deciding factor? The deciding factor that decides what type of motion this body is going to do is speed or velocity. I hope up till now it is clear to everyone. Can I have some raise hand that all these points are clear and that we'll not forget it? Boys, are we there in the class? 2 boys, only one is raised hand. Okay, great. Now let us move on to the next points. Up till point number 4, we were discussing about tension or normal reaction. But apart from tension or normal reaction, in point number 5, we find out that apart from tension or normal reaction, there is also one more thing that you must be concerned about, which actually decides, because they are dependent on each other. They are dependent on each other. What is dependent on each other? What is dependent on each other?
Speed or velocity.
Speed or velocity is the same thing, because we are not concerned about direction here as such. So speed or velocity are dependent on each other, but here we have used speed or velocity as the same term, because I'm not very worried about the direction. And so speed or velocity is not the thing that I'm talking about. Still, point number 5 tells us something, that two things are dependent on each other, two quantities are dependent on each other. That is clear from point number 5. What are the two quantities which are dependent on each other? This is not speed and velocity. Speed and velocity are gone in chapter number 1. What are the two quantities that depend on each other in this circular motion?
Tension or normal, sir.
Read point number 5 and see, you must have something in here. Point number 5 clearly says that speed, or in, if you want to say it as velocity, speed or velocity at lowest point decides whether tension or normal reaction becomes 0 or not. Then I ask you a question: what are the two quantities that depend on each other? And the answer that you give me are speed and velocity, or tension and normal reaction. Can you be so stupid? No, you are not so stupid. You have some brain here, I know that, which are you are not using, and that is not acceptable. Tension. Tension is in mass attached to a string. Normal reaction is in body moving on a circular track inside surface. They are not related to each other, bacha. They are not related to each other. That was one case, that was different case. How can you relate tension and normal reaction, yaar? Use your head. The two quantities that decide each other or depend on each other are tension and speed, or tension and velocity. They depend on each other. They have some relation between each other, not tension and normal reaction. Bhai. Does it? Is it so difficult to understand? No, it is not difficult to understand. But you have not paid attention to the previous classes, and that is why all these things are coming. You have not seen any equation that we have made. Maybe that is the reason. I don't know, bacha, but this is unacceptable that after so many days and something written right in front of your eyes, you are not able to make the relation. Maybe my question was not clear enough, but the question was there. We have talked about tension till now. Now we will move our focus from tension to speed or velocity. Remember, speed or velocity here are used as the same term because I'm not very concerned about the direction. When I'm saying speed, I mean instantaneous speed. Whenever I'm saying velocity, I mean instantaneous velocity. Instantaneous speed and instantaneous velocity are related to each other. Instantaneous speed is the magnitude of instantaneous velocity. If you add direction with instantaneous speed, it becomes instantaneous velocity. Here I am not concerned about the direction. The direction is always tangential. I know that. I'm not very concerned about the direction. I'm more concerned about the magnitudes here. Direction I will draw in the diagram and I will make sense out of these. So the things that are dependent on each other in this circular path are tension on one hand or normal reaction for the circular track and the speed with which the body is moving. These are the two terms that are related to each other. They decide the value of each other in one sense, and that is what I am thinking about. Point up till point number 4 or point number 5, we were discussing about tension. Now let us get our attention into the speed or velocity. Now again, if I go back to point number 1, and again let us go through point number 1. Point number 1 clearly states that tension or normal reaction becomes zero, the particle leaves the circular track. Okay. If I go to point number 2, it clearly states that tension or normal reaction can never become zero in the lower half. Tension or normal reaction can never become zero in the lower half. But remember, apart from tension, and I will not say tension and normal reaction, I just don't want to confuse the two. Either it is tension or it is normal reaction. I'll just say one of those. Either it is speed or velocity, I will not confuse, I'll just say one. So tension can never become zero in the lower half. But there is one more thing that I must be concerned about, the speed. Now imagine a pendulum, and the pendulum moves like this, ting, ting, ting. Simple pendulum moves like this. This is the mean position, the lowest position. It goes up to a certain height, it comes back, it again goes up, it again comes back, it again goes up, it again comes back. It is always moving in the lower half of the circular motion. Do we understand this? Do we understand that that a simple pendulum is always moving in the lower half of a circular track? Yes or no? It is the example of a mass attached to a string. Do we understand this, bacha? Can I have some reason that we understand this? Everyone? Okay, good. So, simple pendulum is the example of a motion that is happening in the lower half of a circle. Very good. Now we know that this circular motion, okay, is happening because of tension in the string. The simple pendulum is made up of a string, and because of tension in the string, the pendulum moves on this circular path. And it is always on the lower circular path. Now, when the simple pendulum goes up, and let me try to draw it here so that it makes sense. I hope you can all see this. So now I'm trying to draw, oops, wrong color. Why I'm using wrong color? If I'm drawing a simple pendulum, and remember, simple pendulum is also a mass attached to a string, tension in the string is T, mass is M, and it moves on a circular path. It's not a semicircle, it's the lower half of a circle. Oops. Let me rub it like this. So it moves like this. It moves like this. It goes to this point, one extreme, then it goes to this point, the other extreme. It is also a type of circular motion. Ting, 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 ting. Now, when it reaches this point A or it reaches this point B, something is keeping on changing. The tension is keeping on changing. Yes, the tension at this point C, if I call this point as C, the tension at point C, tension at point A, and tension at point B are different. If we talk about something else, remember there are two things that you must always talk about. One is the tension and the other one is the speed. What do you think is the speed at point A or point B? Remember, point A or point B are the highest point in this pendulum motion. What are the speeds or velocities at point A and point B? Remember, this is also a circular motion. What do you think are the speeds or velocities, magnitude of velocity at point A and point B? Anyone? What is the speed at point A? What is the speed at point B? I'm only concerned about the magnitude. I'm not concerned about the direction. A and B are the highest point on this pendulum. What are the speed at point A and point B? It has got nothing to do with physics. It is simple common sense. Anyone? Online class, offline class? I want to make a point, and if you know the answer to this, if you can think about the answer to this, the point becomes absolutely clear. You have to use your brains. The brains will start working because, bacha, whatever I do, out of 40-45 questions that you are going to have in your exam, not all 40 and 45 questions 100% will come from the question that we deal in the class. There might be one or two questions which might be requiring you to use your brains and understand the logic and then give the answer. If you don't use your brain, you just keep on mugging everything, you will not be able to answer those two or three questions, and those two or three questions will make the difference of you coming in top 10. If you're coming in top 10, you will run down to top 100. If you're coming in top 100, you will run down to top 500. If you're coming in top 500, you will come down to 1000. If you're in top 1000, probably you will end up at 10,000. But those two questions make a lot of difference. Again, repeat my question. What is the speed or velocity at point A and B? If you don't know the answer, well, the speed and velocity at point A and B has to be 0 because that is the highest point in the circle. When they reach that point, they stop and then they take the backward step, and that is how they come back to their original position. Simple harmonic motion has been done in your class with the other sir? Yes or no? What is happening in the other class? Please tell me, bacha. What is the topic that you are discussing in the other physics class?
Work, power, and energy. So completed.
Work power and
Sir was teaching IP.
I'm not able to get. I mean, gravity.
We are having IP classes, sir.
Okay, the other sir is not teaching anything. He was teaching gravitation, I think. No, he's not
All
taking it.
completed, sir.
Gravitation completed.
Yes, sir.
Simple harmonic motion completed.
Completed, sir.
Okay, then he must have taken this motion of a pendulum. No, he has not
Sir,
taken.
right now we are only focusing on IP, sir. We have
No.
no NEET classes except your class, sir.
Okay, okay. Sorry. I mean it's difficult for me to understand what is happening. So the other sir, I mean the sir who was teaching you NEET classes, he has finished his classes. He is not taking any more classes.
No, sir.
Did he finish gravitation?
Yes, sir. Completed.
Did he finish simple harmonic motion?
Yes, sir.
Okay, that is what I wanted to know. And now he is not taking any more classes, right?
No, sir.
Okay, so you might have seen this motion in simple harmonic motion. No, you have not seen it. This is the extreme position. This is the extreme position A, extreme position B, and this is the mean position. Do you remember this from the simple harmonic motion concept? Remember this? No, not.
Yes, sir.
Okay, so this is the mean position, and I'm doing the same thing in circular motion. This is also a part of a circular motion. This is also circular motion. Yes, it is. It has an angular velocity omega. It has an angular frequency. Everything is same. Okay, so when it reaches the maximum points, the extremmost points, the velocity or the speed, I'm just only talking about the magnitude. I'm not worried about the direction as such. The speed is zero. Yes or no? Do we agree on this?
Yes, sir.
Now, so speed becomes zero. But we all know that tension is not zero. So if I call this tension as Tc because tensions are different, if I call this tension as Tb because tensions are different, if I call this tension as Ta, tension at point A because tensions are different, Ta, Tb and Tc can never become zero. No matter how high it goes, tension cannot become zero. But you can see something else becoming zero in the lower half. If a particle is moving in the lower half, whether it is moving as a string, as a mass attached to a string, or it is moving on the inner half of a circle, out of tension and normal reaction, both of them cannot become zero. But one thing will definitely become zero. What is that quantity that becomes zero? The tension is not zero. If I say tension, that also means normal reaction. I am moving in the lower half of the circle. My tension can never become zero. My normal reaction, if it is a circular path, does not become zero. But what does become zero? My speed is the only quantity that can become zero. So if a particle is moving in a circular path in the lower half of the circle, the only quantity that can become zero is your speed or velocity, because your tension or normal reaction can never become zero. And that is the next point in the lower half. In the lower half, only the speed or velocity can become zero. Do we understand this? We are talking about two physical quantities here that we are concerned about. The first physical quantity is the tension or the normal reaction. The second physical quantity is speed or velocity. These are the two quantities that decide the entire nature of this circular path, circular motion, and these are the two quantities that we are concerned about. In the lower half, only speed can become 0. Do we understand this? Okay. So in the lower half, tension cannot become 0. It's the speed and speed only that can become 0. Now let us do one thing and let us concentrate now onto the middle points, point B and D. Now, when I say point B and D, what do I mean by point B and D? When I say point B and D, I am concentrating on the diameter of the circle. I'm concentrating on the diameter of the circle, point B and point D. Now we have seen that at point B and D, tension can become 0. Tension can become 0 at point B and D. What about the speed? Can speed also become 0? Now, this might be difficult for you to comprehend, so I will not insist much on this. I will just ask you to write this. Point number 7, tension T and speed both can become 0 at the same time. That is, if tension at point B, you understand the meaning of point B? I will write at middle points. You understand the meaning of middle points here?
Yes, sir.
Middle point means the points that we were discussing in the first diagram. We had lower half, we had upper half, then we had the diameter. Those are the 2 points that I am talking about. If tension at point B or tension at point D is equal to 0, this will imply that this will imply what? That the velocity at point D or velocity at point D is also 0. So that means both of them will become 0 at the same time. Do we understand this? Do we understand this? Okay, well done. Please put your hands down. Now, the next condition is, and again, what I'll do is to draw the diagram again so that we are not confused. So I move on to point number 8. Now, this point number 8 is a continuation of point number 7. So I've drawn a circle. I've drawn a circular path, and I'll only draw my points of intention. My point of intention are point A and point B, and I'm drawing the case of a bob attached to a string. This is point O. This is point A. This is tension at point A. This is tension at point B, tension at point A, and tension at point B. In fact, tension at any of the points is different from each other. I hope you understand this. Now, as I said, the most important factor that decides what type of circular motion it will happen depends on speed. Basically, it depends on speed or velocity at the lowest point, and that I have illustrated in point number 5. If I again read point number 5, speed or velocity at the lowest point A decides, the deciding factor is speed or velocity at point A. At point A. The lowest point, point A. What is the speed at point A or the velocity at point A? That is the deciding factor that decides everything in this circular motion. What type of circular motion will happen? How high it will go? And it is very easy to understand. If the speed at point A is very high, it can just keep on moving like this. Dung, 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 dung. If the speed is very low, it will just go slightly up and then it will come back. Then it will go up. So the deciding factor is speed or velocity at the lowest point. And now we are going to understand at what speed what happens. You don't have to understand why it happens. You just have to remember the values that I am giving you. And at the end of this discussion, I will give you the equations from which you can get these values on your own. If you are interested, you can derive them yourself. You can derive it yourself. You don't need to because that is not asked in NEET. But I'll give you for your academic purpose. So let us now see. I have to relate how speed or velocity at point A is going to make difference in our lives. Now, I'll give you values. Now, the first thing that I'm going to do is I am going to give this bob a push, and the speed at point A, it might look like a random number. Let us say that the length of this string is L, and I give the bob a velocity which is exactly equal to root of 2gl, root of 2gl. Now, if I do this, and that is point number 8, if the speed at point A is exactly equal to root of 2gl, then what happens? Then what happens? Please remember this. Then the particle goes up to point B, stops, and continues its motion in a semicircle. I hope you understand what I mean by a semicircle. So it will go up to point B. It will go up to point B, dung, 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 through the red path. Then it will come back. Oops, color has not changed. It will go up till point B. Then it will come back in the green path. It will come back in the green path. up till this point D. Will come back in the green path up till this point D, and then it will go back again. Then it will go back again to point A, then to point B, then to point A, then to point B, then to point D, and it will perform the motion like this. Do we understand this? Can I have some raised hand that we understand this? Now, apart from understanding this, you have to also understand what happens to the velocity at point B. What is the velocity at point B? Remember, the velocity at point A that is given is root 2 GL. In this particular case, what happens? In this particular case, what happens? Velocity at point B becomes 0. Tan, tan. Velocity at point B is 0. Most important factor that you must remember. When the velocity at point A, which is the lowest point, is exactly root 2 GL, root 2 GL, root 2 GL, then the velocity at point B, oops, wrong color. Then the velocity at point B becomes 0. Velocity at point B becomes 0. So it will go up till point B and it will say, okay, I can't go any further. I'll have to go down. Then it will go to point D. Now, just apply a bit of common sense. I told you what is happening at point B. Can you tell me what will be the velocity at point D or speed at point D? Please tell me. It's simple common sense, no physics. What will be the speed or velocity at point D?
0, sir.
Yes, it is 0. It has to be 0 because whatever height it reaches on the right hand side, same height it reaches on the left hand side. At the highest point on the right hand side B, speed is 0. At the highest point on the left hand side, speed has to be 0. Simple common sense, no physics involved. But remember, we have to be concerned about two things here. Two things. Those two things decide the entire motion. Right now, we discuss the speed at point A, at point B, at point C, oh, not point C, at point A, at point B, at point D. There is one more thing that I must take care because the question may be either for finding out the speed or the next thing. What is the next thing that I must concern? Speed, I have talked about. What is the other thing that I must be concerned about? Second thing.
Tension, sir.
Tension, yes. Everyone has tension for exam. Right now, we must be concerned about tension at point A and tension at point B. For first question that I'll ask is, Bacha, tell me what will be the tension at point B? And I've already discussed it in the previous point. What will be the tension at point B? It has already been discussed in the previous point. So you can tell me
0,
that.
sir.
Yes, yes, that is how you relate things, bacha. That is how you relate things, and that is how, if you pay attention in the class, you will have nothing to do. You can do nothing in the other classes at home if you pay attention in this class. So tension at point B has to become 0. This tension becomes 0 at point B because the velocity becomes 0. This is the only point where this happens, both becoming 0. Both becoming 0. Then if you know the tension at point B, you can easily tell me the tension at point D. What is the tension at point D?
0, sir.
That is also 0. That has to be 0. Nothing can stop it from becoming 0. These are the only 2 points where such things happen. Velocity and tension both becoming 0 because on the lower half, tension can never become 0. Only the velocity can become 0. But in these 2 points, B and D, both can become 0 at the same time. But it only happens under one condition. What is that condition? What is determining the tension and velocity at point B and D becoming 0? There's only one thing that determines it. What is that thing? What is the most important thing that determines that the tension and velocity at point B or D will become 0?
Tension and speed both become 0 at midpoints.
When? What is the condition of it becoming 0? Again, you are not reading what is written on the board. The only deciding factor that decides the motion of this particle is what? Is the speed or velocity at point A. If the speed or velocity at point A is exactly equal to root of 2GL, 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 root of 2GL. Keep on repeating it 1,000 times in your head. Root of 2GL, root of 2GL is velocity at point A. Lowest point is root of 2GL. Then velocity at point B becomes 0. Velocity at point D becomes 0. Tension at point B becomes 0. Tension at point D becomes 0. The last question is, what is the tension at point A? I've talked about tension at point B. I've talked about tension at point D. I've talked about speed at point B. I've talked about speed at point A. I've talked about speed at point D. What is the tension at point A? That is the last question. And how do I find it out? So, to find it out, what do? I draw the free body diagram. The mass of the block is mg, so the weight mg is going down. Then I will write the equation of motion. Equation of motion will be written. Equation of motion will be written. I can write the equation of motion in 3 directions. In 3 directions, I can write the equation of motion. The first one is the tangential direction. Force in the tangential direction at point A is 0, so there is no force, so I don't write any equation. Equation number 2 is the force in the radial direction. What is the equation in the radial direction? Tell me, anyone. Inward force is tension at point A. Outward force is mg. T minus mg is equal to mva square by L. Do we understand this? Yes or no? Can I have some raise hand that we understand this? From here, I can find out the value of tension at point A. How much is the tension of point A? I know the velocity at point A. I know the velocity at point A. Can you tell me now what is the tension at point A? Fatafat, 1 minute. If you put the values, what will be the answer of tension at point A?
MVA square by L plus mg.
It will be equal to 3 times mg. When you put the values, bacha, you will get the answer as 3 times mg. And that is what I was looking for. That is equation number 2. If I have to write equation number 3, force in the perpendicular direction is 0. There is no equation. The only equation that you can make is for tension is equation number 2. And from that equation number 2, you can find out tension at point A. And that is the last thing that you must understand in this entire entire conversation. The deciding factor is velocity at point A. If the velocity at point A is root of 2GL, the tension at point A becomes 3 times mg. The particle will go up till point B or point D. The velocity will become 0 at point B or D. The tension will become 0 at point B or D. The velocity, if the velocity at point A is exactly equal to root of 2GL, in that case, tension at point B becomes 3 mg. Do we understand this? Yes or no? So the deciding factor is the velocity at point A. If it is equal to root of 2GL, this is the case that we have done. In the next class, we will be doing more cases. I hope when you come to the next class on Monday or Tuesday, whenever it is, you will have a reading of this, what we have done in the night before the class. Will you do this? Promise me, everyone with a raised hand. Boys, well done, bacha. I'll see you in the next class. I hope you have understood this class. Any doubt, you can always come to me. Take care. I have taken 5 minutes extra. Sorry for that. I had to finish this and I had to take the extra time. Take care. Have a nice day. The class is over. You can move on. Take care.